Problem number 1. The integral of e raised to x times cosine 2x dx. The first thing that we're going to do is we're going to order these terms using the commutative property, and that will give us the integral of cosine 2x times e raised to x dx. And then we're going to evaluate this using the partial integral formula, which is the integral of u dv is equal to uv minus the integral of b du. Now, I'll make cosine 2x as the value of u, and that will give us the derivative of u, which is du, is equal to negative sine 2x times 2 dx. And then, I'll make e raised to x as the value of b, and the value of dv would be e raised to x dx. And then, if we're going to input these values in the partial integral formula, the term would be like this. The integral of cos 2x times e raised to x dx is equal to cos 2x times e raised to x minus the integral of e raised to x times negative sine 2x times 2 dx. And then we're going to put the constant from this term to the left. So we will have cos 2x times e raised to x minus negative 2 times the integral of e raised to x sine 2x dx. And then we are going to order this again using the commutative property. And that will give us cos 2x times e raised to x plus 2, because negative times negative is positive, times the integral of e raised to x sine 2x dx. And then we're going to evaluate this using the properties of integral, and that will give us cos 2x times e raised to x plus 2 times sine 2x times e raised to x minus the integral of e raised to x cos 2x times 2 dx. Now we're going to write the equation u as expression. So the integral of e raised to x cosine 2x dx is equal to cosine 2x times e raised to x plus 2 times sine 2x times e raised to x minus 2, the integral of e raised to x cosine 2x dx. And then we're going to distribute 2, so it would be like this. The integral of e raised to x cosine 2x dx is equal to cosine 2x times e raised to x plus 2 sine 2x times e raised to x minus 4, the integral of e raised to x cosine 2x dx. And then we're going to move the expression to the left hand and change sign. So the integral of e raised to x cosine 2x dx plus 4, the integral of e raised to x cosine 2x dx is equal to cosine 2x times e raised to x plus 2 sine 2x times e raised to x. And then we will collect like terms. So 5, the integral of e raised to x cosine 2x dx is equal to cosine 2x times e raised to x plus 2 sine 2x times e raised to x. And then we're going to divide both sides by 5. So it would give us the integral of e raised to x cosine 2x dx is equal to cosine 2x times e raised to x over 5 plus 2 sine 2x times e raised to x over 5. And then we're going to simplify this one. So it would give us the integral of e raised to x cosine 2x dx is equal to cosine 2x times e raised to x plus 2 e raised to x sine 2x over 5. And then we're going to add the constant c. So the final answer would be cosine 2x times e raised to x plus 2 e raised to x sine 2x over 5 plus c. And that is the final answer for the problem number 1. Problem number 2. The integral of 2 to infinity times the quantity of 1 plus x cubed raised to negative 1/2 dx. Since this given problem is an example of improper integral because it involves an infinite limits, first thing that we're going to do is we're going to integrate the integrand, and we're going to use the u substitution. Now let's make 1 plus x cubed as the value of our u, and that will make du, the derivative of u, is equal to 3x squared dx, and the value of x is equal to du over 3x squared. Now let's substitute these values to our given problem. So we will have the integral of 2 to infinity u raised to negative 1/2 times the value of dx, which is du over 3x squared. Since du over 3x squared, or we can just say it, 1 over 3x squared is a constant, we can write it outside the integral sign. So we will have 1 over 3x squared, the integral of 2 to infinity, 1 over square root of u du. Now, 1 over square root of u du, we can write it as 2 over square root of u using the power rule of integration. So we'll have 1 over 3x squared times 2 square root of u. Now, if we undo the substitution that we did on this part, we will have 2 times the quantity of 1 plus x cubed raised to 1/2 over 3x squared. Now, after we integrate the given, now we need to set it as a limit of integration. So we will have limit as x approaches positive infinity is equal to 2 times the quantity of 1 plus x cubed raised to 1/2 over 3x squared minus limit as x approaches 2 is equal to 2 times the quantity of 1 plus x cubed raised to 1/2 over 3x squared. Now, if we're going to solve this one, the answer would be 0. And if we're going to solve this one, the answer is 1/2. So 0 minus 1/2 is equal to negative 1/2 plus our constant c. And that will be the answer of number 2. Problem number 3. The integral of 2x cubed plus x squared plus 2x minus 1 over x cubed minus 2x squared plus x minus 2 dx. First is we're going to take the partial fraction of this one, and that will give us 2 plus 5x squared plus 3 over x cubed minus 2x squared plus x minus 2. Now we need to factor the denominator, which is this one, and that will give us 2 plus 5x squared plus 3 over the quantity of x minus 2 times the quantity of x squared plus 1 is equal to 5x squared plus 3 over the quantity of x minus 2 times the quantity of x squared plus 1. And then we get the partial fraction for each factor, and that is equal to a over x minus 2 plus bx plus c over x squared plus 1. And then we need to multiply this one by their common denominator, and that is x minus the quantity of x minus 2 times the quantity of x squared plus 1 multiplied to 5x squared plus 3 over the quantity of x minus 2 times the quantity of x squared plus 1 is equal to a over the quantity of x minus 2 times the quantity of x minus 2 times the quantity of x squared plus 1 plus bx plus c over the quantity of x squared plus 1 times the quantity of x minus 2 times the quantity of x squared plus 1. Now we need to cancel out this one, and this one. And that will give us 5x squared plus 3 is equal to a times the quantity of x squared plus 1 plus bx plus c times the quantity of x minus 2. Now we need to get the standard form of this one. And that will give us 5x squared plus 3 is equal to ax squared plus a plus bx squared minus 2bx plus cx minus 2c. And then we need to group the terms and the constant terms. So 5x squared plus 3 is equal to the quantity of a plus b times x squared plus the quantity of negative 2b plus c times x plus the quantity of a minus 2c. And then we need to get the coefficients of two polynomial must be equal, so we get equations. So a plus b is equal to 5, negative 2b plus c is equal to 0, a minus 2c is equal to 3. So the value of a is equal to 23 over 5, the value of b is equal to 2 over 5, and the value of c is equal to 4 over 5. Now, we need to substitute these values in the original form to this one, the original form. So we will have 2x cubed plus x squared plus 2x minus 1 over the quantity of x minus 2 times the quantity of x squared plus 1 is equal to 2 plus the value of a, which is 23 over 5 over x minus 2 plus the quantity of b, which is 2 over 5x plus the quantity of c, which is 4 over 5 over x squared plus 1. And that is equal to 2 plus 23 over 5 times the quantity of x minus 2 plus 2x plus 4 over 5 times the quantity of x squared plus 1. Now we get the integral of this term, and that is equal to the integral of 2 plus 23 over 5 times the quantity of x minus 2 plus 2x plus 4 over 5 times the quantity of x squared plus 1 dx. And then we are going to apply the sum rule, and that is equal to the integral of 2 dx plus the integral of 23 over 5 times the quantity of x minus 2 dx plus the integral of 2x plus 4 over 5 times the quantity of x squared plus 1 dx. And we will have, and that is equal to 2x plus 23 ln times the absolute value of x minus 2 plus 1 over 5 ln the absolute value of x squared plus 1 plus 4 arctan x over 5. And now we're going to simplify this one, and that will give us 2x plus ln the absolute value of x minus 2 raised to 23 over 5 plus ln the absolute value of x squared plus 1 plus 4 arctan x over 5 plus the constant c. And that is the final answer for problem number 3. Problem number 4. The integral of cotangent x minus x cosecant squared x dx from 0 to pi over 2. First, we need to simplify this form. So we have the integral of cosine x over sine x minus x over sine squared x dx. And then, we need to integrate this one by parts. So we have the integral of cosine x over sine x dx minus the integral of the integral of x over sine squared x dx. First, we need to integrate this term using the u sub. So we have, let's make sine x as the value of our u, and that will give us the value of u would be cosine x dx, and then dx would be equal to du over cosine x. Now let's substitute these values to this term, giving us the integral of cosine x over u times the value of dx, which is du over cosine x. Cancel this one, leaving us du over u is equal to ln the absolute value of u, and then we're going to substitute back the value of u, which is sine x, and that is equal to ln the absolute value of sine x. Moving to the next term, which is the x over sine squared x dx. Now let's make x as the value of our u, and that will make du is equal to dx. V would be equal to negative cotangent x, and dv is equal to 1 over sine squared x. We're going to integrate this one using the partial integral formula, which is the integral of u dv is equal to uv minus the integral of b du. So we will have the integral of x over sine squared x dx is equal to negative x cotangent negative minus the integral of negative cotangent x dx. And that will give us negative x cotangent x plus ln the absolute value of sine x. Now let's combine this one and this one. So we will have ln the absolute value of sine x minus the quantity of negative x cotangent x plus ln the absolute value of sine x. Now let's cancel this one, leaving us x cotangent x, and then evaluate it from 0 to pi over 2. So we will have pi over 2 cotangent pi over 2 minus 0 cot 0. Now if we evaluate this one, the answer would be pi over 2 times 0, and if we evaluate this one, the answer would be 0. Pi over 2 times 0 is equal to 0, minus 0 is 0, and that is the final answer for our problem number 4. Problem number 6. Show how to use shell method to derive the formula for the volume of a right circular cone with base radius r and height h. So the diagram of a right circular cone would look like this. And if we plot the half right side of this cone to the Cartesian plane, it would look like this. We have the height h, the radius r, and the points r and 0 and h. So the first step that we're going to do is we're going to find the slope. And the formula for finding the slope is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So m is equal to 0 minus the value of y sub 2 is equal to 0 minus the value of y sub 1, which is h. And then the value of x sub 2 is r, and the value of x sub 1 is 0, so r minus 0. So we will have m is equal to negative h over r. And then y is equal to negative h over r, x plus h. Now this is the slope, and then this one is the slope, this one. Now we have the formula for the volume. V is equal to the integral of, from a to b, 2 pi r times x times f of x dx. So we have the limits 0 to r. So v is equal to the integral from 0 to r 2 pi x times the quantity of negative h over r x plus h dx. So we'll have v is equal to 2 pi h, the integral of from 0 to r, the quantity of x minus negative x squared over r dx. Now if we're going to integrate this one, we will have 2 pi h times 1/2 x squared minus 1r times 1/3 x cubed, and evaluate it from 0 to r. So we will have v is equal to 2 pi h times 1/2 r squared minus 1r times 1/3 r cubed minus 0. So we will have v is equal to phi r squared h minus 2/3 pi h r squared. And if we're going to simplify this one, it would be the volume is equal to 1/3 pi r squared h. And that's how to derive the formula for the volume of a right circular cone with base radius r and height h. This would be the final answer. Problem number 7. Find the length of the curve y raised to negative 3 over 2 is equal to 8x plus 3 from y is greater than or equal to 11 raised to 3 over 2, but not less than or equal to 27 raised to 3 over 2. First is we're going to graph this one, and the graph would look like this. And we have the limits from 11 raised to 3 over 2 from 27 raised to 3 over 2. And then we're going to solve for x using this equation. Y is equal to negative 3 over 2 is equal to 8x plus 3. So we will have y raised to negative 3 over 2 minus 3 is equal to 8x. Divide both sides by 8 to cancel this out. X is equal to y is equal to negative, y is raised to negative 3 over 2 minus 3 over 8. Now, we need to find the first derivative of this value of x. So we will have the first derivative of x would be negative 3 over 16y squared times the square root of y. Now let's solve for the length of the curve using the formula L is equal to the integral of square root of 1 plus the first derivative of x raised to dy from a to b. Now let's input the values. We have the integral of square root of 1 plus the quantity of negative 3 over 16y squared times square root of y squared dy from 11 raised to 3 over 2 from 27 raised to 3 over 2. Now solving this one, we will have the integral of square root of 1 plus 9 over 256 y raised to 5 dy from 11 raised to 3 over 2 to 27 raised to 3 over 2. Now if we will input this one in the calculator, we will have L is equal to 103.81 units. And that is the final answer. Problem number 8. Find the surface area of the object obtained by rotating x plus y squared is equal to 1. Y is greater than or equal to 0 but not less than or equal to 3 about the x-axis. Now if we're going to graph the equation, the graph will look like this. In the first step, we're going to solve for y using the equation x plus y squared is equal to 1. So we will have y is equal to the square root of 1 minus x. So if y is equal to 0, x would be equal to 1. And if y is equal to 3, the x would be negative 8. Now let's solve the surface area using the formula SA is equal to the integral of 2 pi y times the square root of 1 plus dy over dx squared dx from a to b. The value of dy over dx is equal to negative 1 over 2 square root of 1 minus x. So we will have the integral of 2 pi times the value of y, which is the square root of 1 minus x, times the square root of 1 plus the value of dy over dx, which is negative 1 over 2 square root of 1 minus x raised to 2 dx. Now if we're going to from negative 8 to 1. Now if we're going to input this in the calculator, we will have a final answer of surface area is equal to 117.32 square units. And that is the final answer for problem number 8. Problem number 9. The integral of x raised to 7 over square root of x raised to 4 plus 1 dx. We're going to solve this using the u substitution. Let's make x raised to 4 plus 1 as the value of our u. That will make du is equal to 4x cubed dx, and our dx would be equal to 1 over 4x cubed du, or du over 4x cubed. And let's make x raised to 4 is equal to u minus 1. Now let's plug these values to our equation. So we will have x cubed times the quantity of u minus 1 over square root of u times the value of dx, which is du over 4x cubed. Now where did we get this? We just separate the x raised to 7 into x raised to 3 times x raised to 4 so that we can cancel this x cubed and x cubed here. And that will give us, since this is just 1/4 and it is a constant, we can just write it outside the integral sign. So we'll have 1/4 times the integral of u minus 1 over square root of u du. Now we're going to solve this using integral. Now we're going to solve this using integration by parts. So we'll have 1/4 times the integral of u raised to 1/2 du minus the integral of u raised to negative 1/2 du. So we will have 1 over 4 times 2 u times u raised to 3 over 2 over 3 minus 2 square root of u. And then the next step is we're going to substitute back the value of our u, which is x raised to 4 plus 1, and we will have 1 over 4 times 2 times the quantity of x raised to 4 plus 1 raised to 3 over 2 over 3 minus 2 times the square root of x raised to 4 plus 1. Now let's simplify this one. So we will have the value of square root of x raised to 4 plus 1 multiply to the value of x raised to 4 plus 1 minus 3 over 6, or x raised to 4 minus 2 times the square root of x raised to 4 plus 1 over 6 plus the constant c. And this is the final answer. Problem number 10. Find the volume of the solid whose base is the region bounded by y plus 1 is equal to x squared and y minus 3 is equal to 0, and whose cross sections are equilateral triangles with the base perpendicular to the y-axis. Now, if we're going to drop the equation into 2D perspective, the diagram will look like this. And if we're going to graph it into 3D perspective, the graph will look like this. Now, side is equal to 2x and x is equal to square root of y plus 1. So, side is equal to 2 square root of y plus 1. So, the area of the triangle is equal to square root of 3 over 4 s squared. So, to find the volume, v is equal to the integral of ax dy from a to b. So, we're going to input the values to this equation. So, we will have v is equal to the integral of square root of 3 over 4 times the quantity of 2 times the square root of y plus 1 squared dy from negative 1 to 3. We will have v is equal to 8 square root of 3 cubic units, or it is approximately equal to 13.86 cubic units. And this is the final answer. Problem number 11. Determine the volume of the solid obtained by rotating the triangle with vertices 3 and 2, 7 and 2, and 7 and 14 about the line x is equal to 12, line x is equal to negative 1, and line y is equal to negative 3. If we're going to graph the equation, the graph will look like this one. And for the volume, we're going to use the formula v is equal to pi times the integral of y squared dx from a to b, and the other one would be v is equal to pi times the integral of x squared dy from c to d. And now for the slope, y minus 2 is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times x minus 3. And so we'll have y is equal to 3x minus 7, and x will be equal to y plus 7 over 3. Now for letter A, which is line x is equal to 12, we will have pi, the integral of x squared dy from 2 to 14 is equal to pi, the integral of y plus 7 over 3 minus 12 raised to 2 dy from 2 to 14. And from that, we will get pi, the integral of the quantity of negative 36 plus y plus 7 over 3 raised to 2 dy from 2 to 14. And next is we're going to put the constant to the left side. So we will have pi over 9, the integral of y minus 24 squared dy from 2 to 14. And if we're going to input this equation in the calculator, we will get v is equal to 604 pi cubic units, or it is approximately equal to 1,897.522 cubic units. That is for the line x is equal to 12. Next is B, which is line x is equal to negative 1. We'll have pi, the integral of negative 1 minus the quantity of y plus 7 over 3 raised to 2 dy from 2 to 14. We will have pi, the integral of negative 3 minus y minus 7 over 3 squared dy from 2 to 14. And if we simplify this one, we will have pi, the integral of negative y minus 10 over 3 raised to 2 dy from 2 to 14. And if we're going to input this one again in the calculator, we will have volume is equal to 448 pi cubic units, and it is approximately equal to 1,407.434 cubic units. And lastly, for letter C, pi, the integral of negative 3 minus y squared dx from 3 raised to 7. And then we will have pi, the integral of negative 3 minus the quantity of 3x minus 7 raised to 2 dx from 3 to 7. Now, if we're going to simplify this one, we will get pi, the integral of negative 3 plus 7 minus 3x squared dx from 3 raised to 7. And from that, we will get pi, the integral of negative 3x plus 4 raised to 2 dx from 3 to 7. And if we're going to input this one in the calculator, we will get V is equal to 532 pi cubic units, and it is approximately equal to 1,671.33 cubic units. Problem number 12. Determine the volume of the solid obtained by rotating the region bounded by 2y squared plus x plus 3 is equal to 0 and x plus 5 is equal to 0 about the line x minus 4 and x plus 9. So if we're going to graph the equation, the graph will look like this. And for the volume, we will use the formula V is equal to the integral of pi times the quantity of outer radius minus inner radius dx from a to b. So V is equal to the integral of pi, the quantity of outer radius minus inner radius dx from negative 5 to negative 3. So the next is we're going to solve for y using this equation. 2y squared plus x plus 3 is equal to 0. So we will have y is equal to the square root of negative x minus 3 over 2. So this will be the value of our inner radius. So for letter A, we'll have the integral of pi times the quantity of outer radius minus inner radius dx from negative 5 to negative 3. Let's substitute the value of our inner radius and our outer radius in the equation. So we will have the integral of pi times the quantity of our outer radius which is from A, which is x minus 4 minus the value of our inner radius, which is the square root of negative x minus 3 over 2 squared dx from negative 5 to negative 3. And if we're going to input this in our calculator, we will get 476.06 cubic units. And for letter V, the integral of pi times the quantity of outer radius minus inner radius dx from negative 5 to negative 3, we will have the integral of pi times the quantity of the value of our outer radius is x plus 9 minus the value of our inner radius which is negative x minus 3 over 2 raised to 2 dx from negative 5 to negative 3. And if we're going to input this in our calculator, we'll have an answer of 122.10 cubic units. Problem number 13. Find the area bounded by xy is equal to 7, xy minus 1 plus 3x is equal to 0, x plus 1 is equal to 0, and x is equal to negative 4. So if we're going to graph the equation, the graph will look like this. Now, the first thing that we're going to do is to find its limits. So, x plus 1 is equal to 0, therefore, x is equal to negative 1, and x is equal to negative 4. So, for the first one, for the area of the first one, we're going to use the formula a1 is equal to the integral of y top minus y bot dx from a to b. So we're going to input the values. We will have a1 is equal to the integral of 7 over x minus 1 minus 3x over x dx from negative 4 to negative 2. Now, if we're going to simplify this one, we will have a1 is equal to the integral of 6 over x plus 3x dx from negative 4 to negative 2. Now, if we integrate this one, we will have a1 is equal to 6 ln x, absolute value of x, plus 3x, and evaluate it from negative 4 to negative 2. Now, if we're going to input this in the calculator, we will have a1 is equal to negative 6 ln 4 plus 6, and that is equal to a1 is equal to 1.84 square units. Now, for the second, we'll use a2 is equal to the integral of y top minus y bot dx from a to b. Now, let's input the values. We will have a2 is equal to the integral of 1 minus 3x over x minus 7x dx from negative 2 to negative 1. And we're going to integrate this using the integration by parts. So we will have a2 is equal to the integral of 1 minus 3x over x dx from negative 2 to negative 1 minus the integral of 7 over x dx from negative 2 to negative 1. And if we're going to integrate this one, we will have a2 is equal to ln absolute value of x minus 3x minus 7 ln absolute value of x, and evaluate it from negative 2 to negative 1. Now, if we're going to input this in the calculator, we will have a2 is equal to 1.16 square units. To find the total area, we're going to add the a1 plus a2, and that is equal to 3 square units. So this graph, the area bounded of this graph is equal to 3 square units. That is the final answer for number 13. Problem number 14. Find the area bounded by e raised to 2 minus x plus y is equal to 2, y is equal to x squared minus 4x plus 7, x minus 3 is equal to 0, and x is equal to 0. Now, if we're going to graph the equation, the graph will look like this. Now, we're going to find the limits. The limits is equal to x is equal to negative, x is equal to 3, and x is equal to 0. Now, for the area, we're going to use the formula a is equal to the integral of the quantity of f of x minus u of x dx from a to b. Now, let's input the value of our f of x and u of x in the equation. We will have a is equal to the integral of the quantity of x squared minus 4x plus 7 minus 2 minus e minus 2 minus e raised to 2 minus x dx from a to b. Now, if we're going to simplify this one, we will have the integral of x squared minus 4x plus 5 plus e raised to 2 minus x dx from 0 to 3. Now, if we're going to integrate this one, we will have x cubed over 3 minus 4x squared minus 2 plus 5x minus e raised to 2 minus x. Notice that this can be simplified, so let's cancel it out, leaving 2 at the numerator. So we will have x cubed over 3 minus 2x squared plus 5x minus e raised to 2 minus x, and evaluate it from 0 to 3. Now, if we're going to input this one in our calculator, we will have a is equal to 13.02118 square units, or approximately equal to a is equal to 13.02 square units. And that is the final answer for our problem number 14. And for the final problem, number 15, the integral of 1 over w sine the quantity of 1 minus ln w dw. We're going to solve this using the u substitution. So let's set 1 minus ln w as the value of our u, and that makes du is equal to negative dw over w, and our dw is equal to w du. Now, let's substitute these values to our equation. We will have the integral of 1 over w sine u minus w du. Now, let's cancel like terms, leaving us the integral of negative sine u du. Now, let's move the constant to the left side. So we will have negative 1, the integral of sine u du. Now we all know that sine u, the integral of sine u is equal to negative cos u. So we will have negative 1 times negative cos u. Now let's substitute back the original value of Ru to the equation. We will have negative 1 times negative cos the quantity of 1 minus ln W. Now let's simplify this one so that we will have cos times 1 minus ln W. And for the final answer, we will have cos times 1 minus ln the absolute value of W plus the constant C. And that is the final answer for our final problem.